Meu nome é Gustavo, eu sou o Managing Director do The Good Food Institute aqui para o Brasil. E eu quero bem rapidamente descrever o GFI, só para quem ainda está entrando em contato com a gente pela primeira vez. Depois disso, eu vou passar a palavra para a doutora Caterine, que é a nossa cientista-chefe aqui do Brasil, nossa Scientific Advisor, que coordena essa área de ciência e tecnologia aqui para o Brasil. Então, o GFI é um instituto, a gente nasce para promover o setor de proteínas alternativas. Nós somos uma organização sem fins lucrativos que trabalha hoje para o desenvolvimento desse setor. A gente tem 4 programas principais, um deles voltados a empreendedores e investidores, então ajudando a abrir empresas e fazer com que essas empresas sejam bem financiadas. Um programa voltado ao engajamento corporativo, então é o nosso trabalho junto com as grandes empresas que estão trabalhando no setor de proteínas alternativas hoje. Um setor voltado a políticas públicas, então tudo que tem a ver com regulatório, governo, etc. E esse setor de ciência e tecnologia. Aqui o nosso objetivo é promover realmente a ciência e tecnologia. Então a gente quer que as pesquisas que são essenciais para o desenvolvimento de setor de proteínas alternativas aconteçam no Brasil também, e que esse tipo de conhecimento que talvez já aconteceu em outros países comece a ser muito dominado pelos cientistas aqui do Brasil. A gente vê o Brasil como um dos grandes potenciais para proteínas alternativas, tanto as proteínas de base vegetal quanto as cultivadas, porque a gente está falando de um país que tem uma enorme biodiversidade, que já tem a indústria muito bem estabelecida, que tem a infraestrutura para vender para os outros países do mundo. Então, a gente está vendo que o Brasil vai ser um polo de desenvolvimento do setor de proteínas alternativas, e por isso que a gente precisa ter cada vez mais cientistas engajados nisso, universidades fazendo pesquisa, centros de pesquisa realmente, empresas públicas, enfim, todo mundo que faz pesquisa, a nosso ver, tem que também fazer um pouco de pesquisa para esse setor. Eu vou passar a palavra, então, para a doutora Caterine, uma pessoa que eu tenho imenso prazer em trabalhar junto com ela, uma cientista de alto gabarito que trabalha junto com a gente, que deu aí o prazer de poder liderar essa área para a gente no Brasil. Caterine, obrigado, e a palavra é sua. Uma última coisa, desculpa, que estava aqui nas minhas atribuições. Temos um sisteminha de Q&A, de Questions and Answers, que vocês conseguem ver aqui. Então, se vocês quiserem fazer uma pergunta, é só clicar ali onde está escrito Q&A, que é no canto aqui embaixo, e aí vocês mandam as perguntas. Todas as perguntas que forem simples, a gente já responde por escrito e elas passam para o setor de respondidas. As perguntas que são mais complexas, a gente vai organizando elas e vai fazer no final para os palestrantes. Por favor, digam para quem você está fazendo a sua pergunta quando vocês fizerem, e provavelmente não vai ter tempo de responder todas as perguntas, mas a gente coloca em contato com os palestrantes depois para a gente poder começar. Desculpa, para a gente poder responder essas perguntas. E aí agora, então, eu vou passar a palavra para a Caterine. A partir de agora, a gente vai falar tudo em inglês. Então, também, se vocês tiverem alguma dúvida em relação ao idioma, vocês entenderam alguma palavra, alguma coisa que está sendo dito, só mandar aqui também nos questions and answers que a gente pode responder. Caterine, muito obrigado.
Obrigada, Gus, pela abertura. Também quero dar as boas-vindas a todos os participantes. Vejo vários nomes já conhecidos aqui participando com a gente de novo. Essa é a nossa segunda edição do webinar, então sejam todos muito bem-vindos. Antes de a gente começar o nosso webinar, eu quero aproveitar para fazer o convite para um webinar que vai acontecer também nessa semana. Não sei se todos sabiam, né, ou sabem, no dia 7 de junho foi o dia mundial marcado, né, para comemorar a segurança de alimentos, então o Dia Mundial da Segurança de Alimentos. Então, para marcar esse dia, o GFI está promovendo esse webinar, agora no dia 10 de junho, então, onde a gente vai falar sobre as questões de segurança de alimentos para produtos de carne cultivada. A gente vai mandar para vocês o link da inscrição, né, para quem tiver interesse em participar. Então, fica aí o convite já para mais um webinar que vai acontecer nessa semana. Então, vou interromper o compartilhamento aqui da minha tela. E agora, então, quero fazer o anúncio das nossas palestrantes. Então, a gente muda para o inglês. So, it's with special excitement that I'm pleased to welcome our two speakers, Birgit and Patrícia, to our second webinar. So let me please introduce our speaker. So Birgit, after successfully defending her PhD research with honors at Wageningen University, and yes, her research focus was on shared cell technology and the structuring of plant proteins. So, after defending her PhD, Birgit decided to pursue her work on the novel shared cell technology to transform fibrous structures into plant-based meat analogs with remarkable texture, taste, and appearance. Driven by a need to restore the balance between animal-based and plant-based foods, she is dedicated to developing products that people want to have again and again. That's amazing. So Patrícia Duque-Estrada, so she is a Brazilian, and she has a background in human nutrition with expertise in nutrient adequacy of plant-based diets. So last November, she obtained a doctoral degree in food technology, also at Wageningen University and Research. And her research topic was about the protein quality of plant protein-based food as a function of iron incorporation and food processing. I would say to prepare yourself to be excited and to be inspired by Birgit and Patrícia today. So without any further ado, Birgit and Patrícia, thank you again for being with us today. And over to you. The virtual stage is yours.
Thank you very much for this very nice introduction and for this invite to give this webinar. So our talk is about the creation of fibrous plant protein foods today, a shear cell technology to texturize plant proteins. So I have to, what we will discuss during this talk is a bit more about shear cell technology. I will also explain how shear cell technology is different from, for example, extrusion, how you can structure plant-based proteins with this. First, a little bit about dairy proteins actually, and then about plant proteins. And then I should give you a short insight about what we do at Rival Foods. So this is a startup indeed that we founded after defending my PhD in September 2018. And I'm very happy that Patrícia also joined this webinar to tell a bit more about nutritional aspects. So this webinar I also gave already a couple of months ago to another community from GFI. And I got a lot of nutritional aspects, related questions. So I'm pretty sure that Patrícia can answer all those questions much better than I can. So I'm really happy that she was able to join today. So first, a bit about shear cell technology. Shear cell technology is developed at Wageningen University in the food structuring group. This is a department within food process engineering, and the goal of this research line to better understand the behavior of dense biopolymer mixtures under mixing and extrusion-like conditions. So this is a long sentence, I realize, but basically the professor Adrian van der Zoot wanted to better understand the black box that extrusion is, both in, for example, the creation of meat analogs, but initially actually mostly for understanding better starch extrusion that is, for example, also used in creating breakfast cereals or pasta and these kind of things. Basically, in extrusion, you have a combination of different effects. So you have the mechanical effect, especially in the barrel when there is a lot of mixing. Also, there is a thermal effect because the whole system will be heated, and that has an effect on structuring of these biopolymers. And actually, the combination of these two actually result in even different effects that you cannot predict by only looking at mechanical and thermal effects. The idea was basically to model these mechanical effects and then understand better what consequences this would have for extruder design. So the first idea to simplify extrusion was actually to look at simple rheometers. So systems that can be used to look at the viscoelastic behavior of biopolymer mixtures. However, if you want to better understand extrusion, then you also use similar shear stresses, so comparable to extrusion. And this is actually not really possible with the rheometer. Also in an extrusion, you have a lot of complex flow patterns that basically ensure that you have a lot of mixing. But this is also very complicated in a sense. So therefore, the idea was to make this more simple and use therefore a homogeneous and a well-defined plane shear field. Basically, a shear field, what you see between two plates. One plate is moving, the other plate remains stationary. That's basically simple shear flow. So the problem with studying extrusion with conventional rheometers, in a nutshell, is you have too high torque values. Basically, if you, for example, have pasta or the mixtures to create breakfast cereals, the viscosity is too high to actually be able to measure it with the rheometer. And then a very practical but crucial problem as well is that in a standard rheometer, the gap to load samples is actually too small. Well, basically with this idea, Professor Alcian started with the design of shear cells. So what is a shear cell device? It's basically a rheometer. It's really based on a rheometer concept. But then the shear stresses that you could apply were comparable to extrusion conditions. And instead of having complex flow patterns, you have more homogeneous and well-defined plane shear fields. The great idea about this concept is that you actually can also study parameters independently. So think about shear rate, temperature, residence time, and torque measurements. So this is the very technical background basically about shear cell technology and how it all started. Often I very quick get a question, how is this technology then different than, for example, extrusion? And this has to do with shear rate, temperature, and residence time, which is an extrusional coupled, and that makes extrusion often what we call a black box. Difficult to predict and difficult to understand, and you really need to get the parameters right to obtain nice, in the end, for example, fibrous structures. But this is also the case in creating, for example, breakfast cereals. What happens in the barrel, basically, so on the left side, you see a typical example of an extruder where you have loading of the proteins together with water. Then you have the intensive mixing and melting and cooking phase, basically in the barrel of the extruder. And afterwards, there's texturization of the proteins of starch in the cooling die. Well, and in this barrel, you have very intensive mixing. And one of the questions also in the research lines was whether this intensive mixing is actually favorable for protein extrusion. We know that this was done always in, for example, starch extrusion. Also, if you look to extrusion, for example, in creating paints or other types of products, mixing was part of the steps of processing ingredients. However, also in the research line for shear cell technology, the question was whether this intensive mixing is actually important. Therefore, we basically simplified it. Then the last difference between shear cell and extrusion is the structuring. In extrusion, basically the main structure is formed during the cooling die, in the cooling die, where you have a laminar flow profile. Basically, the material flows out of the extruder and is cooled from both sides. And what you create is a kind of plug flow, which you see in the bottom picture, depicted with an A in this side. And this is very nice for example, creating chicken-like pieces. Then these extrusion parts are pulled apart, and you can create nice products with it and a good bite. Then I come to the first discovery, basically, of creating structures with the shear cell. So actually, in the beginning of using shear cell technology, most research was going into defining these rheological behavior of these dense polymer systems. And the idea was of a certain research project to understand interactions in cheese, actually. And therefore, they used sodium caseinate. But on a regular day, one of the students actually made a mistake. And instead of using sodium caseinate, the students grabbed calcium caseinate. And it was basically a coincidence that they found out that with this technology, you can also create fibrous structures, as you can see here in the picture. Basically, what they found that it was possible to use shear cell technology to create fibers on a very different length scales. So on the left side, you really see the macroscopic fibrous formation, long and strong fibers. And on the right, you see that we could also create fibers on a much smaller length scale. And this work was done by Julita Mansky and Jiajing Wang. So here you can even see it better, the structure formation of calcium caseinate. In this example, for example, also fat was included. So 30% calcium caseinate and 15% fat. And we were able to really create nice, longer and thinner fibers by using this combination. This is an example of a microscopy picture where you can clearly see actually how structure formation works in this system. In the green areas, you see proteins, and in the red area, this is the fat, which is basically aligned in the shear flow direction that we apply. So this is a confocal scanning laser microscopy where we were able to really see these two phases by using different probes. So the green probe was for protein and the red probe, in this sense, how you see it, was for the fat layers. And then we used even different types of microscopy to go even deeper into the structure formation on a smaller length scale. Here you see fiber formation even on the micro to nano scale, so fibers from approximately 100 nanometers. And this length scale was at that moment, so this is already quite old work, a thought that is very important also for creating the typical mouthfeel that you, for example, also have when you're consuming meat. Basically, after this research, of course, it was very interesting that you could create structures with dairy proteins, but for sustainability reasons, I guess I don't have to explain this. Also, plant proteins were, of course, of interest. And that's what the next research line was about. So can we use plant-based ingredients to structure them into fiber structure? And the interesting thing, what we found is that you can. Basically, you see a lot of examples here. So we were able to use flours, protein concentrates, protein isolates from a wide variety of protein sources, such as soy, wheat, and pea. This is the initial work. And right now, also at the university, they're investigating more exotic proteins, plant-based proteins. So think about, for example, proteins from rapeseed, from sunflower, potato, quinoa. And it all actually, in the end, depends on the shear cell conditions that you use, the formulation, the preconditioning of the ingredients. So it's not that you can just throw everything into a shear cell and you can create structure. There is knowledge needed to do this, but we have been able to create a lot of different structures with different plant proteins. So here you see on the left side, homogeneous gels, layers, thin fibers and thicker fibers, basically going from left to right. And basically, during my research, I really focused on how can we create fiber structures from plant proteins. So this is another example of just an image where you see how these types of structures look like, really zoomed in very far. And what you can imagine is that these types of textures, this is also something that you would see when you have cooked meat, for example. So if you would prepare a piece of chicken fillet and you would pull it apart, then a similar image you could find like this. This was done with a reflected light microscopy. I already talked a lot about shear cells. Here you just have some images of those. On the left side, you really see a nice laboratory shear cell. It's a conical device, so basically you have two cones, and in between you put the material. Basically, the bottom cone is rotating, the top cone is stationary, and in between you can deform the proteins. On the right side, you see an upscaled version of this machine, of the shear cell. This is a couette cell, so basically different geometries. You have two cylinders instead of two cones, but the shear flow deformation is basically the same. In this case, the inner cylinder is rotating, the outer cylinder remains stationary. The proteins will be in between these two cylinders. Like in extrusion, also these devices are heated to a certain temperature depending on the ingredients and the formulation. And subsequently, you cool the system down to then take out the samples. So this is a batch process. So this was a short introduction of shear cell technology. Now I can show you a short movie of what we're doing. I hope this works well. At Rival Foods, I have to figure out how I can actually start the movie itself.
Is this movie in another platform that I could find and maybe bring here? Like YouTube?
Yeah, I also have another version on my laptop, but usually it should work if I do it like this, but I guess it doesn't. Well, basically I can show you the movie at the end of the presentation as well. Then I find it when Patrícia is talking. It's not a problem. Basically what I tell in this movie, I can also shortly introduce it, is that there is a market gap in plant-based proteins at the moment. So if we look at animal-derived products, basically very general speaking, you have two types of products. You have the processed meat products and the unprocessed meat products. On the left side, you see processed meat products. You think about burgers, sausages, these kind of things. On the right side, you see unprocessed meat products and even fish products. So filet, loin types of products. The holy grail would be, for example, steak. Well, if you now look into the markets, you clearly see that there are already alternatives for the processed meat products. So probably you will know Beyond Meat, Impossible Foods, but also other players are entering this market by introducing plant-based versions of these processed meats, so of the burgers, of the sausages, and as explained already, also with high moisture extrusion, you can create chicken pieces. However, on the right top, you see that there is a market gap for these unprocessed animal-based products. And this is where we see the shear cell technology comes in. Hopefully this movie works. So this is basically what the process looks like. What we first do is we mix proteins with water. Then you can get a kind of dough. So these are hydrated proteins. This we put into a filling device, basically to pump the proteins in between the two cylinders. Then we have the shearing process. So basically you see the inner cylinder is rotating, the outer one stays stationary. Then we cool down the whole system, and then the plant-based meat is ready. So this is basically what it looks like. You have a thick slab of product. So in this case, this example of 7 kilograms with a thickness of 3 centimeters. And with this, we are now creating plant-based products that address the culinary space. So world's first whole cuts from plants. Basically, from the research side, we know that we can create a range of textures, as I showed you before, depending on ingredients, process conditions, formulation. And with this, we create 3 product categories: rival at sea, rival on land, and rival with wings. So these 3 different types of textures form the basis of these products. And then together with color and flavors, you can create products that really fill that market gap of whole cuts. Our products are very high in juiciness and also can be neutral or flavored and colored. So on the right hand side, you see basically the starting point, this large slab of meat products. Those you can then shape and cut into different types of shapes, of course, fitting to, for example, the portion of animal-derived products. But besides that, you can also use it in a much more creative way. So you can cut it into all types of shapes, whatever you want. And chefs and food professionals are really excited about this. So going back a little bit to shear cell versus extrusion. So what you see here is the shear cell profile that we can create. So this is this different type of flow that you see, and therefore you can create really different types of textures. So on the left top, you really see these fibrous textures appearance, where on the bottom in extrusion, you see this layered laminar flow profile. And this really is suitable for different types of products in the end, different applications. So these are just some examples of products that we are now creating. So loin types of products, also round shaped products, all including flavor and are very high in juiciness. Of course, I would love to share this all with you already, but we are still in a development phase at Rival Foods, and we expect to have products introduced in the market soon. Here, there are already some chefs that have tried it before you, and they are very excited to work with these products. So even in the whole slabs, in the large size, but also in smaller portions, as you can see, they're really excited about these products and find it a true innovation. So this is the Rival Foods team. We now are with 8 people, and on the second one from the right, that's Professor Adrian van der Goot. So basically the inventor of this technology and still professor at Wageningen University, dedicated to do research to structure plant-based proteins for this application. So this was a short introduction from my side. And now I think we will continue with Patricia's presentation, and then I will try to get the video up and running so that we can see that after her presentation. Thank you.
Okay, hi everyone. So now I'll share my screen with you. So, as Beat already introduced, I will talk about the nutritional aspects more in a general, not really presenting my PhD thesis, but more in a broad idea of nutritional aspects of plant-based food, but also structure plant-based food. So basically, I prepared my presentation thinking about common questions that I encountered during my PhD, also Beat. And these questions were related to if meat analogs should have a similar nutritional composition and quality as meat, how the processing, the shear processing was affecting protein quality, especially regarding digestibility, and if we should consider any incorporation of micronutrients to the product in a way, again, to reach similar nutrition composition as meat. So first, let's understand a bit why meat is so special in terms of nutritional aspects. So meat is the main source of high protein content and a high protein quality. What does this mean? It means we have meat provides all the indispensable amino acids for human requirements. So this indispensable amino acid, it means we cannot synthesize in the body, so we need to consume from the diet. And highly digestibility as well. There are other components that make meat so special in terms of nutrition, which is the being source of certain micronutrients. And heme iron is a quite special element that we only find in meat products. And basically because heme is available in hemoglobulins and myoglobulins. And there are two types of dietary iron. So one is the heme iron and the other one is non-heme iron, which you can find also in meat products, but basically all plant-based food contains non-heme iron. And the main difference between these two forms is that heme iron has a higher bioavailability compared to non-heme iron. Zinc, which is an important essential mineral to human nutrition, and the main source are meat. You can also find in plant-based food, however, the bioavailability is lower, mainly because plant-based food, there is anti-nutritional effects that can decrease the bioavailability of such mineral. Another vitamin that is quite important is vitamin B12. It's very important for production of red blood cells, synthesis DNA, and you can only find this vitamin in animal proteins, so not just meat, but also eggs, milk. Heme iron and vitamin B12, while the deficiency of both micronutrients can result in anemia. Actually, iron deficiency is the most common nutrient deficiency all over the world. Therefore, you see that there's a lot of range of products with fortified iron so that we can cope with this deficiency. Okay, so this makes meat quite important for human diet, the presence of high quality protein, the presence of certain micronutrients. However, there are some components that makes meat not so special. And this is the high content of saturated fat acids and cholesterol. While saturated fat acids has been described with increasing plasma concentration of cholesterol. Of course, this is connected if you have a high intake of meat. Red meat is also probably a carcinogenic to humans. So this was actually classified by the World Health Organization in 2015, while processed red meat is considered carcinogenic to humans. For example, a consumption of 50 grams of processed meat daily can increase about 18% the risk of colorectal cancer. So of course, meat is very important to our diet. However, there are some components that if you have a high intake of proteins, of meat proteins, and not a balanced diet, you can develop some chronic diseases or even some types of cancer. So this is a high motivation to change towards a more plant-based diet, not just for sustainable reasons and also animal welfare, but for health. Okay, now that we understand a bit why meat is so important for human diets, I will first, before I answer this question, if meat analogs should have the similar nutritional composition and quality as meat, I would like to show you a comparison that I prepared. So here on this table, I used burgers because it's very common that we find plant-based burgers in the market. So I chose plant-based burger and a beef burger from the same brand, a popular brand in Brazil, and a very famous plant-based burger in US compared to a famous beef burger also in US. So I would like to point out between these comparisons some positive and negative aspects. Positive is that while it's very easy to reach similar protein content in these products, since most of the plant-based products use concentrate or isolated protein. So in this case, it's not really difficult to reach high protein content. However, we should not only focus in protein content, but in protein quality. And I will talk a bit about this later. Regarding total saturated fat acids, I found that, for instance, the American burger has almost a similar protein saturated fat acids content compared to the beef burger also in Brazil or US. So this is, I don't find very positive. However, there are some brands that the saturated fat acids level is lower. So this is negative, I would say. A positive aspect is that meat is not really a source of dietary fibers, and these can be found in plant-based products, so either incorporated or as part of the ingredient, depends on the ingredients that are being used. Another negative aspect is the amount of sodium in these products. So if you take a look here, the plant-based versions have similar amount as the beef burger. While of course sodium is a very important element in processed food, but I believe it should be an aim to reduce the amount of sodium in such products. I didn't point out iron and vitamin B12, however, often these micronutrients are being incorporated in the plant-based version, which I find quite relevant. Not determined here is not that it's not present in meat, it's just I could not find the information. So one point that is important to consider regarding iron is the form of iron that is being added to the products, because there are several non-heme irons that can be incorporated. However, these irons, they have different bioavailability. So it's important to choose a form of iron that has a high bioavailability. So to answer this question, if meat analogs should have similar nutritional composition and quality as meat, I would say it depends. It depends on the eating frequency of someone. So it depends on the target. Who are the consumers of this product? Are they going to replace meat 100% in their diet or partially replace meat? And their diet composition. So if you have a balanced diet, maybe you don't need, meat is not really the main source of proteins and essential amino acids. So therefore, I think it really depends on the purpose of such a product. However, if it's meant for someone who has a poor protein intake and essential amino acids and certain vitamins and minerals, then I would say it should be similar to meat. One aspect that I think that meat analogs should aim to be equal or even equal as meat is regarding protein quality. And this is where I would like to talk about a bit, because it's not just about protein content. So protein quality means the ability to meet human requirements for amino acids. And it depends on the source and the food processing that it's applied. So here are some aspects to consider when you want to evaluate protein quality of a food. First is protein content. If you are curious or maybe you don't know this information, for instance, the adult protein recommendation is an intake of 0.8 grams of protein per kilogram body weight per day. And usually we see that often there is a high intake of proteins in the diet, and most of the time this is not even necessary. Another point that is important to consider is the presence of indispensable amino acids, because the quantity of these amino acids can limit the nutritional quality of the food. So FAO has described a new score to evaluate the protein quality based in digestible indispensable amino acid. This is a score actually. I'm not going into details the calculation, but just for you to understand what is it and how you can use this score. So the score is based on the true ileum digestibility of indispensable amino acids, and you can calculate for each amino acid. And therefore you have to divide such values for amino acid requiring partner. Therefore you reach a score. So if you calculate the score for all the amino acids, the lowest score would determine the limiting amino acid of that food. And this score will actually be the overall score of that protein. So if you want to make, for instance, you're developing a product, you think to make a claim about the protein content, you should also consider the protein quality. And this is where you can use this score. So basically, if you have a score of 100 or even higher, it means you have a high quality protein source. If you have a score of around 75 and 99, it means you have a good quality protein source. But if you have less than 75, it means you cannot make a claim of a good quality protein source. So quickly, I want to show you, this is a nice table where you have different protein-rich foods from animal proteins and also plant proteins. The values of the score and the limiting amino acid of each one. So for instance, if we would make a claim for the soy protein isolate, this would be a good source of quality protein. You can see that most of legumes have a limiting amino acid methionine, while grains like rice have lysine as limiting amino acid. So a nice way to overcome this imbalance of limiting amino acids is to combine, to make blends of different sources of plant proteins or blends of plant proteins with animal proteins. So for instance, here in the bottom, if you check corn-based breakfast cereal without the milk, the score is very low. But when you include milk, you increase this score. So you increase the quality of this food. Another nice combination is very typical, Brazilians will love it, is rice with beans. Therefore, with this combination, you can balance these limiting amino acid patterns. It's good to remind that, of course, it's important a balanced diet, and it depends on the quantity of each food source so that you can reach all the essential, indispensable amino acids in your diet. And the last item here is digestibility, which is just the ability to break down the proteins and absorb the amino acids. And digestibility can be affected by physical or chemical changes in your proteins, and also if there is the existence of substance that can inhibit the digestion and or the absorption. So this is just a tip of a nice website that I found. It's called vProtein. If you're curious to find good partners of plant proteins to reach all the indispensable amino acids, you can just Google and play around a bit. So they basically did an algorithm for matching plant-based food on the basis of complementary amino acid content. However, they do not consider digestibility. So this is just based on the amount of these indispensable amino acids present in the food regarding the reference. So if you're curious, you can go there and play around a bit. Okay, what about food processing? I received a lot of questions during my PhD about this topic, and this was actually part of my thesis where I investigated the effect of processing on protein modifications. And actually, depending on the environment that you are producing the food, so there are different chemical and physical environments, it will also lead to different effects on nutritional quality. So there are several protein modifications that can happen. And I would like to point out that actually there is a lot of reactions induced by heat and high pressure processing. There are some advantages of heat processing regarding nutritional aspects, and one is the inactivation of anti-nutritional factors. This is mainly due while you don't use really isolated protein sources, and the improved digestibility. So in some cases, this has been described for extrusion, for instance. You can denaturate your protein and therefore expose more hidden sites for protein digestion. And one of the disadvantages of heating process is the reduced bioavailability of nutrients, and I will explain a bit more on the next slide, and sometimes production of anti-nutritional or toxic compounds. So among the reactions that can happen in food induced by heat, food oxidation is very common, and food oxidation can happen not only in protein-rich food, but also in fat-rich food. And a very common oxidation that's actually a reaction between reducing sugars and proteins, it's called Maillard reaction. You probably are familiar with this. Maillard reactions can form several different products. It depends on the degree of the reaction, and some of the products has been described as having antioxidant capacity, while other products have been described to have highly carcinogenic activity. One of the amino acids that most induced to suffer protein modifications, amino acid modifications, is the lysine. So there are several studies showing how to control the losses of lysine during extrusion. For instance, depends on the parameters, on the temperature that you use, the moisture content of the food. And there are several derivatives from lysine that can be formed, and therefore these derivatives have different bioavailability. What does this mean? Well, sometimes there is a derivative that you can absorb, but it's not going to be useful anymore for your body. And sometimes the lysine derivative it did not cause a change that you can still use. It's still useful, that amino acid, for your body. So really depends on the derivatives. Regarding protein oxidation, which is our focus here, and was the topic of my thesis, there are a lot of studies with meat proteins. Actually, my thesis was the first one analyzing protein oxidation in plant processed food. There are studies regarding using protein isolate or concentrate, but not really processed plant-based food. So these, all these effects for human body are related to studies with meat, and especially with animals, so experimental animals. So this is related, the results are related to loss of essential amino acid, as I mentioned before, for instance, with lysine, that you have a certain modification in your amino acid that is not going to be valuable for the body anymore. Some dietary oxidized food has been described to induce oxidation stress in vivo. And regarding digestibility, it depends on the level of the modification. So when you have high oxidation, it can decrease digestibility, but on the other side, if you have low oxidation levels, it can increase digestibility, it can improve digestibility actually. So here I just want to show an example of one of our results. This was a work that I did together with Bihet during our PhD. So we investigated the effect of processing the shear cell technology on gastric digestion in vitro. And we tested different matrices. And here I'm just going to show the results of soy protein concentrate. So in this graph, we have the degree of proteolysis per time. And we have two types of samples. So the black curve represents the soy protein concentrate just in water, so a suspension of this ingredient. And the yellow curve represents the shear cell samples grounded. So we just use a kitchen mixer to ground and make very small particles. So what is actually for the soy protein ingredient, which is our control, it's not really further processed. The curve is very similar to protein suspensions, that you have this rapid increase in the beginning of the digestion, and then a slow down and reaching a plateau. Regarding our samples, the sheared samples, we see that actually structuring slowed down the proteolysis rate. However, after even 2 hours, you see that there was no difference anymore between the ingredient and the sheared sample. So actually here I just show this curve represents the sample produced in 120 degrees, but we did not find any difference between 100 or 140 degrees. And as I mentioned, the process actually slowed down the proteolysis. And we also try to find a correlation between the effect of processing in protein modification. So I measure also protein oxidation in the same samples, and we wanted to understand if this would impair digestion. And actually we could not find a clear correlation. So it seems, at least for gastric digestion, that the modifications that were made during processing did not impair digestibility. So just to conclude, I believe that meat analogs should actually be better and healthier than meat products, and aim to have a high protein quality. It's quite beneficial to incorporate iron and vitamin B12, especially if these products would be consumed for people that have a low intake or they don't consume meat at all. So far, there is no study showing that the high temperature shear cell can impair digestibility. Of course, our study was just based on the gastric phase, so more studies of complete digestion should be done and bioavailability of these amino acids. Food processing, actually, the effects on the nutritional aspect will depend on the parameters and also the composition of the ingredients. So before I finish, I just want to ask your help. I'm starting a consultancy, sustainable solution-based startup together with partners Claudine and Joyshri. We all graduated from Wageningen University, and we have a survey to try to understand challenges in agri-food and bio-based industry. with the aim to develop sustainable solutions. So actually, I will share a link in a bit in the chat. So if you are a small company, startup working in the agri-food biotechnology field, and you're facing some challenges, I would like to ask you please to reply our survey. So I would like to thank your attention and of course the Good Food Institute for the invitation. I'm really happy I could participate in this webinar. If you have further questions that maybe we don't have time to answer today, you can always contact both of us, and you can also directly connect with us on LinkedIn if you just scan the QR code. Thank you.
So are you ready to start the Q&A?
I am.
Would you
yes.
mind? Yes. Mm-hmm. So let's start with the first one. Can you see the questions, Birgit? Yes.
Yeah. So the question is, what kind of fat was used with calcium caseinate, dairy fat or vegetable fat? In this study, it was actually palm fat. So of course that also has some negative notes, palm fat. But actually, this calcium caseinate palm fat system was really something that was used to study these types of systems. Nowadays, in the plant protein structuring processes, we look into different types of fats that can be included in our process up to a certain concentration. I hope this answers the question of for me, I think.
Just so the next one, yes.
Yeah, so Felipe asks, wet extruders with double cannons are really expensive in Brazil. How much does it cost a shear cell machine compared to wet extruder in a scalable industrial level? This is a good question. Unfortunately, I cannot answer it yet. So basically what we're doing at Rival Foods is basically, developing this technology further and commercializing it as well. The state of the art right now is that we were able to scale from 100 grams to 7 kilograms. And further upscaling to industrial level is necessary to be able to compare it to, for example, extrusion. So we are not there yet. At the other side, what I can explain as well is that an extruder is quite a complex system. You have this barrel with screws inside, indeed, and this is very expensive. Well, basically, if I really simplify a shear cell, you can compare it to a pressure cooker with a rotating part in it. So basically, it's very simple. You have two cylinders. In between, you have the proteins, and the whole system is heated, and you apply the simple shear flow. For example, the torque values are very low. So in essence, it's much a simpler process, and therefore also the equipment is simpler and can be cheaper. But at the same time, we didn't scale it up yet. So this is something that we are working on at the moment. Then the next question, are they mostly based on legumes, grains, or other different kinds of plants? So basically our main prototypes right now are made of soy, wheat, and pea proteins. But we also have shown on a smaller scale in the research lines that also other types of ingredients can be used. So both legumes, grains, also oil-rich seeds besides soy. The next question, what differences you noticed when extruding soy, pea, and wheat in terms of structure, texture, taste, performance? Yeah, this is a good question. So indeed, if you use different types of plant proteins, also the structures are quite different. One of the things that I can share right now is that, for example, if you use soy proteins, the gelling strength of these proteins are higher than if you compare it, for example, to pea protein. This is just very generally speaking. So with that already you can make different types of textures. Moreover, the ingredient extraction processes, so the way you extract these types of proteins to create either isolates or concentrates, also affects the type of texture that you can in the end create, the type of taste that you have. So it's both, of course, the original plant-based source that you use, as well as the extraction processes and then the structuring process that you use, which all have an impact on the structure, the texture, and the taste of your final product. And then the next question, seeing the photos of the grilled products, the texture reminds me a lot of a thicker salmon fillet. I couldn't see, that doesn't matter, I guess. The question is, have you tried to use it as salmon fillet? So indeed, we have different types of textures that we can create. Also, we can create this kind of layered types of products, which also really reminds indeed of fish types products. So we are doing product development in 3 product lines, you could see. So at sea, on land, and with wings. And indeed, the at sea product line is mimicking more fish-like products. Then the question from Philippe. Are there any particular taste differences between extruded ingredients and ingredients after using a shear cell machine? Is it needed to insert different levels of flavors? This is not an easy question because I haven't studied my self-extrusion process in a great detail. What I can say is that adding flavor to a dense protein system is quite a challenge because often flavors are bound to the protein matrix, and therefore you need quite high concentrations if you compare it to other products that use flavors. One of the advantages that we have with shear cell technology over extrusion is that the conditions that we use are typically milder than extrusion. So the temperature is slightly lower. The shear rates are definitely much lower. And also this is expected to have an effect on flavor as well. But this is really a field that is still needs further exploration, I think, to improve flavor in these types of products. The protein concentrate is a processed food. Is there an alternative to use the whole legume? Interesting question. Yes, this would be great if this would be possible. So far, unfortunately, we haven't been able to create structures in merely protein flours, or although we are indeed in favor of using the least processed ingredients. What I expect is that you do need certain pre-processing of your ingredients, so isolating or separating some components to be able to create structure, but the idea and the goal, the long-term goal, is to indeed use only mildly refined ingredients. One of the research line at Wageningen University, so it's not at Rival Foods, but at Wageningen, is indeed separating ingredients in a very mild way. For example, for pea protein, you can imagine air classification where the processing is limited if you compare it to conventional extraction processes that are nowadays mostly used to create protein concentrates or isolates. I guess that was me. So now I give the word to Patricia.
Yes. So there's a question from Marina. What about the calorie intake of the same amount of protein, meat in plant-based alternatives? One of the cons of substitute conventional meat to plant-based in terms of how is the great amount of carbs that are intrinsically paired with proteins in plant-based alternatives. Yes, that's true. But if you see processed plant-based versions that they use mainly, especially if they use isolate proteins or concentrate, there is a lower carbohydrates compared to using just the grain, for instance, or compared with a vegetarian diet that you eat beans or other types of legumes. So, and that's the main difference, I would say, if you were talking about plant-based, not including the processed meat analogs, or if you're just thinking about a diet using legumes and rice as they are. And indeed, there is vegetarians, they consume more carbohydrates, but still you can have a balanced diet, you know, and as I showed, there is not a need of such high intake of proteins in the diet. There is a minimum that we must consume, and then this can be reached by a vegetarian diet, for instance. So I guess it depends on the products that are used, the food that is used to reach the protein requirements. Another question from Gabrielle is, to improve the nutritional profile of plant-based burgers, what do you recommend should be done? Well, as I mentioned, at least comparing those products that I showed would be the sodium content and saturated fat acids content. But again, this is to make like the ideal product, no? Because actually depends if this product would be consumed on a daily basis, how many times per day that this would have a negative impact for someone's diet. So I would say this, and including the micronutrients like iron, vitamin B12 is quite important, since when you take meat, meat is the main source of these micronutrients. Okay, the next one from Marina. Is there any way to reduce soy or other protein alternatives like peanuts substance related to human allergy? I'm not sure if I understand fully this question. To reduce the soy. So you mean if how can we reduce the allergies? Yeah, the components in soy or other legumes that can induce allergy reactions. Is this the question?
Maybe the effect of the technology in the allergenicity of the soy.
Yeah, how to reduce this, yeah. So yeah. Often the process to isolate the soy proteins or other legume proteins, you already exclude these factors. So, but I'm not really specialized in this topic. But I believe that most of these components are excluded during the fractionation process, when a soy protein concentrate or isolate are used. Another question from Anasato: is there any association between the protein functionalities, characteristics as gelling properties, hydrophobicity with the final product submitted to the shear cell? I guess, well, for both of us, I think. Well, I investigated the effect of processing in hydrophobicity, not gelling properties. In terms of hydrophobicity, when I compared with the ingredients of the soy protein concentrate or isolate, there was a reduction in hydrophobicity. And then we compared the effect of these with digestion. And it's true that, for instance, soy protein concentrate had slightly higher hydrophobicity compared to soy protein isolate. And this could explain the difference that we find when we compare digestion between soy protein concentrate and isolate. So because the hydrophobicity status actually determines how is the state of your protein. So if the protein is more packed, or if it's more open, more exposing these hydrophobicity sites. So this is what I studied during my PhD. Beat, do you want to add something? I don't know.
Yeah, I guess that's after structuring. So if I can answer the question basically of protein functionality, so ingredients such as gelling properties and hydrophobicity, indeed, it really determines structuring. The level of hydrophobicity of your isolate and concentrate also impacts structure formation. So that's basically the answer if it would be before processing on the ingredient level. I hope this is a clear answer from the both of us, that we answered it. If not, then please reach out and let us know.
Another one for me, from Mariana. Did you evaluate amino acid bioaccessibility? No, I didn't have time to evaluate these.
Is there anyone else working on this topic at Wageningen University?
No, I don't think so. Not that I know. I think it should be a further study, of course, and also go into understanding more which modifications happen, because I focus only in one type of modification during the process. So there are several modifications that you can find and try to correlate going further in the digestion steps, because I focus on the gastric. But at least for the gastric, we didn't find any really negative point. I mean, it slowed down the protease rate, but you can reach similar degree as the protein source, the ingredient. Now I think it's to be.
Yeah, so the next question, the mass obtained in the shear process is wet. Does it need to keep refrigerated or frozen? Yeah, that's a good question indeed. It's wet, so we use typically between 50 and 70, mostly towards 70% of water, and a lot of proteins. So if you would keep this at room temperature, then the microbes really enjoy it as well. It's very nutritious for them. So indeed, hygienic design and keeping these types of products refrigerated or frozen is indeed important. At the same time, during processing itself, we are heating these proteins and water. And if we pack these types of products right away after processing, and you have hygienic design, then the amount of microbes that are in your product are very low. If you compare it to, for example, meat, where you have already several microorganisms actually growing, you can imagine that this is even more important, more crucial. And then another aspect is, of course, the refrigerating and freezing step, how that impacts the products. And this is actually beneficial to our products. So structure isn't lost or even gets a bit better after a freezing step. So I see there's no open questions.
I have just one question, Patrícia. Have you suggested a translation for shear cell technology to Portuguese? Or do you have any recommendations?
Oh yeah, we talked about this. The shear cell, I think, is translated as, no, I forgot, cisalhamento. I think this was what we talked. Should I talk in Portuguese? I'm confused.
Yes, please.
Eu acho que a gente tinha conversado sobre isso, né? Cisalhamento. Mas eu sempre evitei, na verdade, traduzir, porque é uma tecnologia. Claro que o shear cell é uma tecnologia aplicada em outros métodos, né? Mas é o nome que eles dão à tecnologia, né, que eles desenvolveram. Então, eu pelo menos sempre fugi um pouco dessa tradução por conta disso. Mas o que a gente tinha conversado era sobre isso, era cisalhamento. Eu posso procurar aqui o que eu tinha comentado antes.
Mas você não chegou a fazer nenhuma publicação em português ainda, né, Patrícia? Todos os teus trabalhos são em inglês, né? Uhum.
Sim, sim.
Bom, se a gente não tem mais perguntas, ainda tem um minutinho, se mais alguém quiser encaminhar a sua pergunta.
I have just one question. Just in this technology, we are looking for fiber, of course, and this will make possible to create like whole meats texture. But is there like one specific kind of products that you think should be the focus for this? Is like with this technology we can start selling this product that was not possible to be done anyway in plant-based? Like, do we have a big category that we are focusing, or will be like in whole meat in general?
Yeah, thank you for that question. Indeed, there are different types of product categories where you can focus on. So basically, we call it at sea, on land, with wings, to not focus on the product itself, like only beef or pork or chicken or turkey or and there are different reasons why we would move into different directions, but we see that with our technology we are actually able to address all these types of products. And what we're doing now is really bringing it together, so these textures, these distinct mouthfeel and juiciness that you get from it, combine that with flavor and color such that it matches as a whole. The Holy Grail, what we're often talking about is for example, a steak. But at the same time, I'm also wondering, and we're often looking into the future, whether this is the Holy Grail or whether we can create products that actually have all the best properties of different types of meat products in the end. So we're then talking about flavor, tenderness, juiciness, the way it fries, that you get a crispy outside and a juicy and soft inside. We are aiming to create the tastiest products that you have ever experienced, and whether this then mimics really pork meat or beef meat. For us, that doesn't really matter, but we are developing those products in different directions, basically. Yeah.
All right, thank you. And is there any application besides plant-based meat? I know that it's a lot already, but any other category besides meat that you think this technology could be useful for?
So fish products, but I guess that's, I'm not sure if that's the question. Basically, the technology, what we've talked about before, is also creating stringy cheeses, for example, could be an application that isn't explored to a wide extent, I have to say, but I guess this could be of interest as well, because also in creating, for example, mozzarella, shear structuring is important.
Good, thank you. Patrícia, there is a question that arrived in Portuguese in the chat. Don't know if you can see it.
Yes.
Maybe you can answer in Portuguese, if Bridget is okay with that.
Yeah. Para fibras de origem vegetal minimamente processadas, quais alternativas de aditivos vegetais naturais não processados para torná-los substitutos não apenas em textura, mas também nutricionalmente? Existe essa possibilidade ou é mais na composição de receitas e combinações que se equaciona a questão? Fibras de origem vegetal, você quer
Uma carne de
dizer...
jaca, por exemplo, alguma coisa desse tipo.
Ah, sim, sim.
Tem aditivos que adicionam nutrição ou só nas receitas não tem como via aditivo?
Bom, eu não sei muito sobre fibras de origem natural. Essa parte eu não sei muito, mas porque na verdade o meu trabalho foi muito com proteínas vegetais também já processadas, então não minimamente processadas, e aí nesse caso é realmente uma combinação de diferentes componentes para você alcançar uma qualidade nutricional mais elevada, né? Em termos de proteína, em termos de outros nutrientes, micronutrientes. Mas em relação a minimamente processados, eu não sei dizer.
Bom, mas se talvez após o webinar, se você também tiver alguma informação adicional, você compartilha com a gente também compartilha com os nossos participantes.
Uhum.
Pode ser, Patrícia?
Claro, sem problema. Vou procurar, na verdade, sobre esse tema.
Maravilha. So time is over, so we have to finish, unfortunately. So Virgin and Patrícia, once again, thank you so much for an enlightening and entertaining presentation. So it was so nice to have you both with us today. So thank you again.
Thank you very much.
Thank you.
E para todos os nossos participantes, mais uma vez, obrigada pela presença, pelas perguntas, pelo interesse. É muito bom a gente estar conectado, né, falando sobre o tema de proteínas alternativas. Essa semana a gente tem mais uma oportunidade também de falar sobre segurança dos alimentos. E aí no tema de carne cultivada, a gente vai mandar para vocês o link para as inscrições. E em agosto a gente tem o nosso terceiro webinar. Em breve a gente compartilha com vocês o tema, os palestrantes e o link também para as inscrições. A gente se encontra. Um abraço, uma boa semana para todos.